Thank you guys for being here. So welcome to the third episode of MEV Space. So MEV Space is bring together all the sharpest minds in crypto to dissect the evolving MEV landscape. So today our topic is about TEE, who's definitely one of the hottest topics in the industry today. We have two great industry leader here in terms of TEE. So we have Xia, who is a product lead at Flashbots, and we also have Chua Zheng Long. Sorry if I'm wrong about the pronunciation of your name. He's a co-founder at Automata Network. So also we have our co-host Blair here. Blair is the MEV solution architect of Fastlane, and it's an honor to have him to be our co-host again. Okay, so I want to start with our speakers. Would you guys might do a brief introduction about yourself, and also what you've been working on regarding TE? Okay, how about we started from Xia.
Sure. Yeah. Hi, everyone. I'm Shay, and I lead the Ethereum products at Flashbots. So we have been using TEs in all sorts of ways in production over especially the last year, but dating back before then with a lot of R&D.
All right. A very good morning to everyone. My name is Zheng Yong. I'm the co-founder of Automata Network. So at Automata Network, we kind of focus on really the machine attestation, basically for all sorts of devices, and trusted execution environments is one such platform in which we can actually verify the authenticity and the integrity of the machines. So some of the things that we are building on now really is for example, the integration of TE into MPC protocols like the WorldCoin AMPC protocol, where the whole iris code thing is actually being executed within a TE. We are also kind of open sourcing a lot of tools in which TE's projects can actually utilize. For example, the DCAP attestation verification library. We are actually in the process of finishing up an audit for the library, so that in a general sense, it can be provided as a public good, and projects can actually build on top of it. So yeah.
Okay, so Blair, would you mind do a brief introduction about yourself? I see your status is connecting, so is there something wrong with your connection? Okay, it seems like Blair is still connecting. So yeah, I'll start with the first question. So my first question is actually about would you guys give a definition on what is TEE and how it's different than MPC or FHE or any other solutions?
It can
Yeah, it'd be great if you can start it, Zheng Long. Thank you.
Sorry, I mean, just now my connection kind of broke, so I didn't catch what did you say.
I think the question was to explain how TEs differ from other things like MPC or FHE.
Yeah, that's right.
Okay. So I think TEs in general, it's kind of to me is a powerful generic tool in our kind of crypto toolbox, where we can use to address some of the problems. So if we are talking about tools, that tools have certain kind of properties, if you think about it. And what TEs can bring to the table really is that one, you get a certain level of guarantees over the integrity and the confidentiality of the computation and data that you are working on or performing within the trusted execution environment itself. Two, it's relatively cheap in terms of running a TE in terms of the the upstart cost of obtaining the hardware that is associated in running trusted execution environments, and the ongoing cost, for example, the computation that is needed to perform such operations. This actually bring into another property of TEs, which is they are actually fast. The kind of overhead that we are looking at, depending on the type of operations that we are doing, is typically in the order of 1 to 2% to maybe in the worst case scenario 10%. So what this gives us is actually a primitive that allow us to do certain time sensitive computations in which we are sorry, let me rewind a little bit. This allow us to do mutually distrusting computation in a time sensitive manner. So if you think about it and extend it further, one of the so-called biggest counter arguments or arguments against using TEs is that, hey, TEs always get broken. There's always hacks that are happening to trusted execution environments. Now, I'm not going to say if ZK systems have hacks or not. They do that. As long as it's a system that's built by humans, that is going to be problems or vulnerabilities or issues with it. But even if we assume that trusted execution environments are, say, inherently broken, or say there's a certain level of probability in which it can be broken, you can actually use it as part of what we call defense in depth, like the security community calls defense in depth, where you layer TE as part of a bigger system to improve the overall robustness of your solution. So for example, the AMPC example that I've mentioned previously, the one with regards to World. So World Network, their iris matching algorithm, they make use of MPC algorithm that assumes a honest but curious adversary. So what this does is that it assumes that everyone participating within the protocol is follows the protocol, but can actually passively monitor the operations that are actually being performed by their machines. So what this actually means is that the MPC protocol will only work if and only if the node operators follow exactly the protocol. That means they can't deviate from the protocol. If they deviate from the protocol, certain guarantees of the protocols will be lost. Now, the interesting thing about how the AMPC protocol is structured is that given if the operators chooses not to follow the protocol, then what we can't be sure about the correctness of the result. That means we don't know if the iris code matches or don't matches, but the privacy of the iris codes are actually still being kept. That's the assumption. Provided there's no collusion between the MPC operators. That's another thing. So in that case, if you consider that scenario specifically, by introducing trusted execution environments into the picture, one, it actually allows the protocol itself, in this case World Network, to ensure that the MPC operators, the node operators, are actually following the definition of the protocol itself. That means it's performing all the steps that is needed by the protocol. The second benefit that it brings is that it actually prevents collusion between all the different MPC node operators. So two of the operators can't get together and say that, hey, let's share our secret so that we can identify all the different iris code that is being stored in the database by sharing the sharded secret. So these are kind of like a concrete example in the real world how TEs can actually be used to augment the what's it called, the security and of the entire system, so to say.
Okay, thank you. So Shea, how do you think of TE? Like, what would be like the biggest advantage of TE if you wanna define it?
Sure, I like them because they're fast. In MEV, to build really good MEV auctions, you kind of want three things. You want them to be private because in MEV, information is money, and you want to make sure that you have strong privacy guarantees. You also really need to run these things quickly. MEV is a few milliseconds make all the difference. And finally, we don't want to have to rely on some centralized intermediary because then you could get censorship or rent seeking or whatever. And the thing about TEs is that in the past you could get kind of a few of these properties. Maybe with things like actually like MPC and FHE, you can have something that's private and possible to decentralize, but they just are really not performant enough to run production MEV use cases. We've actually tried a couple prototypes of FlashBots, and the runtimes are just insane. What's nice about TEs is actually you can get pretty good privacy and integrity guarantees that let you kind of architecturally decentralize who's running your auction, but do it really fast. And I think that's especially in the last year, that's been the big unlock, especially with new kinds of TEs that came out and that we've been using, like TDX.
All right, Blair. So do you have any questions regarding TE in a general perspective?
Yeah, I told you I'd have trouble with Twitter Spaces. Happens every time. I would be curious to learn more about, particularly Shay, your journey through going from, so you guys started out with Suave, and you obviously worked on that for a while and have since focused more on the design space of TEs and BuilderNet. And I would love to know more about that journey and like what insights you had from starting with Suave that led you to focus on the TE design space.
Yeah, okay, that's a good question. I think they're actually not as different as you might think. So we actually had a lot of the ideas that you see in BuilderNet today a while ago. I think it's something like either the first sentence or the first paragraph in the Suave post on the Flashbots writing site. This is from 2+ years ago. Talks about the goal of creating a decentralized block builder. I think it's literally the first sentence in that post. And in particular, It talks about like how do we address the risks of exclusive order flow and cross-domain MEV that might giga-centralize all of Ethereum. That was kind of the concern. And I think also like we've always known that privacy tech is really key to building good MEV markets and auctions and products. Actually, also a fun fact here, this was before I joined, but one of the first prototypes of what Flashbots was in the early days was supposed to run in SGX. Like there was I think it was like an SGX builder or something. So we had been like these two things, this goal of creating a decentralized builder and this like instinct that you need really good privacy tech to accomplish that goal. The sort of like seeds of these ideas were there a while ago. But I think the real thing was just we were really early. Both the R&D on privacy technologies, like I mentioned, we've done experiments with a bunch of different things and all of them were just really slow. And also the market. I think candidly, like, identifying a possible future risk is really different from people actually experiencing those externalities in practice. And so I think for a while we iterated our way there. We focused on products like MEV Share, I think, is an interesting example, which is both this like early example of an experiment with private searching and how you use privacy to create better auctions, and also at the same time, it was like a solution for this very real need to share MEV back to users and order flow providers. Same with some of the early sort of like Suave Centauri work that we were doing. But I think where all of these early ideas then like come to a head and make sense with the work we're doing today is kind of in the last year, both the sort of R&D on TEEs and the actual like market need for a decentralized builder came to head at sort of the same time, because there were a bunch of, as I think they have been dubbed, the order flow wars, which had accelerated, to the point where like the market was becoming giga centralized and block builders were turning into basically more like glorified BD shops than they were necessarily spending all of their time accelerating the technical frontier, which also some of them just like really disliked doing. And we also discovered TDX then. It's been out for a while, but I think we actually finally got our hands on it and started benchmarking it, and we just realized, oh my gosh, you can run stuff in this at native speed, and those factors, the like fact that exclusive order flow was actually a big problem in the market. It was causing problems for builders, for basically everybody, and also the fact that we can now run block builders in TEs at near native speed, which is like something I don't think anybody really believed even a year ago. That became the basis of BuilderNet, which is this network of TE block builders, and you can use this. It's already trying to deliver on some of those goals of Suave, like addressing exclusive order flow, and also cross-domain MEV, because we're working on using BuilderNet to sequence other rollups too. So I hope that kind of ties it together a little bit.
Yeah, I think it does, and I think you're right. Like I think I can't remember when that post came out when you guys did the benchmarking, but it was definitely surprising to the upside of how fast it was and how achievable some of these things that you guys are trying to do are when you do have those sorts of speeds. It's cool to see. Shua, on your end, I'd love to hear more about your journey into TEs and like what over the past year. What have you seen? What improvements have you seen, and what you guys are working on, and kind of your journey into going all in on the whole TE world?
Thank you, Blair. So with regards to kind of like TEs, I totally agree with Shay that it is really a very kind of like useful component or useful tool that we can use to kind of like improve block building in general. So if you think about it, like one of the biggest issue or problems that we have about block building is actually information asymmetry, and the fact that we don't really have a mechanism to enforce like code as law, basically, because like you have to trust that the what's that called, the builders or the proposers and the relays are actually behaving as intended. There's a sort of a social layer over it. TEs actually enable us to truly decentralize the entire environment, because it removes the need for this kind of like social level trust in it. That's one, actually. So with regards to kind of like my history or like our journey for TEs, Automata Network actually started in 2020. So it has been like 4 years already. 5 years actually. So like what Shay mentioned, we actually worked with Flashbots quite closely initially. For example, like for the what's it called, the Suave, the attestation verification portion of the of the kettles are actually done using our decad solidity contract. So like I mentioned previously, our focus really is in kind of like identifying or like establishing the kind of like root of trust to all the different machines that we are actually running. How do we know that that machine is actually a real authentic trusted execution environment, a real Intel machine, so to say. So we like our kind of like foray into MEV actually started like 2 years ago. I think in end of 2023, we actually wrote like what Shay mentioned, because at that point in time there wasn't TDX, there was only SGX, and then we have been working on SGX for a while now. We actually wrote kind of like mainnet Ethereum block builder from scratch. It's actually open source. If you're interested, you can take a look at it. So one of the kind of like issues back then is that SGX is kind of hard to use compared to TDX. So a little background for some of our audience or listeners is that SGX uses a process-based trusted execution environment, while TDX uses a virtual machine-based trusted execution environment. So in that case, if you want to kind of like run your programs, your software in SGX, there's actually a need for you to rewrite the software in order for you to kind of like in order for the overheads actually not to be way too high. For TDX, it's a lot easier because you can just run most of the software is unmodified directly within the VM itself. So with the so we kind of like started back then, explored building some. We actually managed to build a few blocks on mainnet itself, and then we realized that our blocks are actually not competitive, like at all, because of certain what's that called, private overflow, private order flows that we are not receiving. So based on purely public transactions, we are actually competitive, but with the inclusion of private order flows, it becomes less competitive, basically. And it was during that period of time where Flashbots actually started their swath. And so we were like, hey, like Flashbots is actually kind of like taking the lead in pushing for the usage of trusted execution environment in MEV and in auctioning, in MEV auctioning. So we were like, hey, why not we'll just kind of like work within the ecosystem, and this is where we are. So kind of like to cycle back, the main focus that we are kind of like more focused on really is still in general TE technologies, but more on the underlying kind of technology. So for example, right now we are still maintaining the SGX SDK. We have actually just bumped it to the latest version. We also have kind of like development of execution environments for kind of like VM-based TEs like AMD SCV and Intel DDX. So you can kind of like run workloads across both. So yeah.
Okay. It's really good to know that you guys been working on TE for such a long time and got so much achievements. So my next question is what's the security considerations and the safeguards that can be used to enhance the TE-based auction implementations? So I still want to start with Shay.
Yeah, so I think there are probably two ways to think about this. One is, how are you actually applying TEs in practice? Because there are, things that TEs are really good at, and then ways that TEs break. And so the kind of overall security of your system kind of depends on how you're actually using them. And I think that the other way to maybe think about answering this question is how can we augment or patch or build more defense in depth around TEs, not just applying them in smarter ways, but also adding other techniques in the mix. And I think right now, we are the most kind of pragmatic thing is the first version of that answer, just because a lot of other cryptographic techniques are just not possible to run performantly these days. And so I think we have been thinking pretty hard about, okay, what are the risks you have with TEs? I think a pretty good example is side channels. So while TEs are supposed to be private, there is a chance, especially if somebody has physical access to the hardware, they could try to tamper with it. You can look this up. People do crazy things to try to get access to the data in the machine. So it's pretty entertaining rabbit hole, actually. But one thing you can do is you can require them to be run in a cloud environment, where the person might not have access to the actual physical machine, which kind of limits the scope of some of the attacks they can do. You can also, in requiring them to be run in the cloud, you kind of have a security model where both the cloud provider and the hardware provider might have to collude in certain cases for a bad thing to happen. And while it's not necessarily perfect, these actors tend to have fairly uncorrelated incentives. So that gives you some extra assurances. This is just one example. I think there's other ways to look at this. In MEV, we're not really using these things for long-term storage most of the time. It's just for kind of very short time windows. So we also don't have to worry as much about some of the other ways that TEs have broken in the past, just because the use case is pretty different. But that's not to say these things are infallible. They definitely aren't. They do get broken. So you have to just have a good way to handle cases where there's a report of an issue, and so building that into your system, having it know how to respond to these kinds of things, being able to ship patches or updates really fast is another thing we're working on. Increasing the release velocity with this, which is not as simple as it sounds. These things are kind of hard to work with still, but we're doing a lot of investment on improving that part of the flow. So I think the thing I would say is it's kind of, you have to think about it in context, and all the kind of ways you're applying it in the protocols you're building around the TEs themselves gives you a much better view of the overall security of your system.
Is it reasonable to think about the security part of it more as like an arms race between good and bad? That you're always going to be defending against negative actors out there?
Yeah, I mean, I think the way, we kind of, you have to make the assumption, okay, there's a chance that some exploit will appear. How do exploits, then what do you do? Basically, you have to actually build in a process for, okay, when something gets exploited, what are the steps we're going to take? How are we going to make sure we respond to it, get the patch from the provider, and roll it out really quickly? Things like making sure you actually have a set of accepted versions in your system, and you boot out versions that aren't safe anymore. These kinds of things. But yeah, you just basically think you have to assume that they're not perfect, and then you kind of build with those risk profiles in mind. I think the one thing, though, that should be mentioned is all of this, while yes, there are obviously risks to these things, I don't even know how to express what order of magnitude better than some of the trust assumptions and dependencies risks we have in the current MEV supply chain. So everything should be everything should be taken, I think, in progress, in context, and seen as, a step in the right direction. You can't, don't let perfect be the enemy of the good, I think is important in these conversations.
Yep, I like that a lot. Shwad, do you have anything to add to that?
Yep. Actually, I totally agree with what Shay just said. It is important to kind of note that even with all the imperfections that TEs have, every single one of them, it's still way better than the trust assumption that we have now. So I would like to actually add one more thing. So if we kind of take a look at the way how we build systems, or how we have been building systems for the past, I don't know, 20, 30 years, there's the whole thing about like OPSEC, right? Like how we have sysadmins that would maintain servers, and then today there's a known vulnerability in the Linux kernel, or there's a known vulnerability in our TLS stack, for example, like Heartbleed. Then the kind of like the course of action is that there will be a release made, and then people would be updating their systems to a new version where it will be patched. Like we have been doing this for as long as we have computer systems, and I think moving forward this is something that we can do. And if you think about that, like let's say we are using TEs to using TEs for short-lived secrets would kind of like minimize the window of opportunity for malicious actors to actually extract secrets or information from the enclaves themselves. Let's say even in the worst case scenario where someone managed to actually compromise a machine, and then we realize, because like in order for the malicious actors to actually effect the compromise into something that is economically beneficial for them, they will have to make it public, right? Then we know that, hey, that machine is actually compromised already. We can immediately kind of like blacklist that machine and remove that machine sorry, out of the set of what's it called, set of authorized set of like okay machines that we have. So this kinds of like flows into the fact that on like how can we actually know that a particular machine is indeed authentic, or the integrity of the machine hasn't been compromised. This goes into a kind of like a protocol that we typically use called remote attestation, where the machine, the trusted execution environment, will actually provide a kind of like proof that, hey, like these are the measurements of my environment. I kind of like sign it using a secret key that only the CPU or the hardware knows about. No one else actually knows about it. If we can actually perform all of this in a decentralized manner, like for example on chain, then it becomes easy for us to actually have very quick responses to this sort of security compromises by blacklisting the key of the compromised machine. And basically that machine, the attacker only has one shot at it, one shot at actually utilizing the compromised machine. And then after that, that machine is as good as useless. So yeah.
Yep, makes sense. That's cool. Taking a little bit of a pivot, I want to double click on BuilderNet, since that is live out there. We get to see how that is performing and talk about that. Shay, how like what is the main benefit of BuilderNet from like a theory standpoint as a competitive, decentralized builder in the MEV Boost auction? So right now you have these 3 BuilderNet builders. What is the kind of the end goal of these builders, and how do you view them from a competitive landscape to, I guess, Titan and Beaver Builder?
Yeah, well, first of all, my express hope is that in the long term, this is a positive sum game. So actually, we are working very closely with, at least with both, well, we've been talking with both of the people you mentioned, and Beaver Build is actually working on migrating to BuilderNet. So I think it's interesting to kind of like reframe how we think about the market today. BuilderNet isn't really about like displacing current block building teams, MEV teams. It's more about creating a better platform for them to build on top of. So, today you have to do a lot of legwork to become to like actually compete in quotes as a block builder, which isn't like building good algorithms. You have to go and you have to invest capital up front. You have to do all this boilerplate stuff. You have to find order flow, convince lots of people to send you order flow, possibly pay out subsidies, just to even be on the top half of Relay Scan. And the idea behind BuilderNet is, let's kind of create an open and neutral alternative to these games people have to play today that aren't really the core value that you're adding as a builder. Let's handle all of that complexity on their behalf, make sure it's really easy for everyone to get access to order flow, make it really easy for people to just kind of deploy programs that can securely coordinate with each other, and free up all the people who are in the market today and hopefully in the future to do the stuff they're really good at. So focus on driving efficiency and finding new alpha and building great features that users love. So, Titan Builder has introduced a bunch of features that searchers, for example, really like. Beaver Build is actually was created because there's a searching team that realized, oh, we have these features we want, and the only way to get them is to run a builder. So I think the idea is just to kind of solve some of these more fundamental table stakes things and make this more, positive sum, open, neutral platform that all of those actors can build on. And in fact, that's exactly what Beaver Build is starting to do today. They're migrating all of their order flow, their software, and everything into BuilderNet. We've been running some benchmarks with them actually, which are quite promising. So yeah, I don't know if I've answered your whole question, but I think that's what I have to say.
Yeah, I think so. No, this is a good answer. And has there been attempts at doing particular strategies that benefit only from BuilderNet? Like, the fact that you kind of can share private order flow, and therefore there are some strategies that might be able to cross-pollinate that order flow in certain ways and order the transactions in certain ways that generate positive sum MEV that you wouldn't be able to do if you were just a builder on your own. What is the current status of those sorts of strategies?
Yeah, no, this is a fun question. So, I think in general we have a sort of thesis that a decentralized builder, and in particular when you distribute the process of block building, like stop thinking about a block builder as a noun, start thinking about block building as a verb, as this process that a lot of people participate in. We think that in that model you end up just building more valuable blocks. And at a high level, that's kind of where we're heading. But I think you're asking for specific examples. So one thing that is, I think, one of the cooler things we're doing right now is letting searchers have access to order flow, to opportunities that right now, in the past, they didn't have any access to. And otherwise, there's like a couple of these sort of special whitelisted, not very secure deals. And one of these is bottom of block arbitrage. So at the end of a block, there's often some additional arb left over, and an atomic bot can find it and split the profit between themselves and the builder, who could maybe even refund that back to everybody else in the block who indirectly or directly contributed to the arbitrage. And what's pretty cool about BuilderNet and about the fact that we have these TEs is we can actually create a secure environment to run an entire atomic bot that can, safely receive state diffs from a builder, construct an arbitrage bundle and send it back. And this is a kind of searching that, at least not in a permissionless setting, has really just not been possible for most searchers to access in the past. So I think that's one cool example. And in the same primitive, this like secure sandbox where you can run proprietary code is something we are very excited about using in other contexts as well. You can use this to just backrun user trades. Maybe this is a next generation OFA. You can also potentially outsource other kinds of the block building tasks, like parts of bundle merging, to one of these nodes. So I think that's like a particular example that we're pretty excited about.
Cool. Yeah. Anything else to add from any of the other speakers?
Nope. But I think maybe a little. This might be a little bit far-fetched, but like I think the introduction of like BuilderNet or like TEs in general that provides both confidentiality and integrity of the computation actually allow us to have maybe a different kind of economic model for like user transactions. If we think about it, like because now we actually have a way where we can kind of like collect private order flows in one central place. Maybe we can have like a an ad-like system, like in traditional Web 2, where searchers, just like what's it called, advertisers, can actually pay to have access to like some of these transactions, and then of course this revenue can actually go back into the user, or like part of it can actually go to the BuilderNet operator to subsidize, to kind of like subsidize the operation of the machine, and to make the whole thing actually sustainable. Yeah, maybe.
Yeah, I also have a follow-up question for Shay. So, what do you think of the biggest missing piece that can incentivize like Jerry from Subway to submit their transactions to BuilderNet?
Is the question like, what's the reason Jared wouldn't submit them today?
Yeah, submit their transactions or bundles to BuilderNet, because I think the current like refunding system is kind of like they cannot give all the money that Jerry could earn in a like a normal sandwich bundle, right? Because you have this like a percentage refund system.
Okay, so let me see. I think so. We've actually designed. So one thing we haven't touched on in detail here, but BuilderNet has a native redistribution, MEV redistribution rule. So every contribution, every kind of extra, amount of value that a given transaction adds to a block will refund proportionally how much profit the builder makes in that block. So you're basically getting paid for how much better you're making the blocks. And the amount of the refund is, because of this, directly correlated with how much order flow the system has. So I think it doesn't really make a lot of sense in this like early, kind of testing rollout period. It doesn't really make sense to be looking at comparing the refunds that BuilderNet has to the size of Jared's order flow, because refunds are just kind of determined by the amount of order flow going into the system in the first place. We actually have spoken with the Beaver team, who Jared sends a lot of their order flow to try to make sure that the way that refunds work in BuilderNet would work for people who are currently using these more centralized deals, and we're fairly confident that the BuilderNet approach will be similar. So I don't think we see there being a huge missing piece. We just want to make sure we give customers, order flow providers, the confidence they need that things like benchmarks and performance between the systems are comparable before we cut things over.
Okay. Yeah, sure. That's a great answer. Okay, so move on. Our next question is about like so Shutter Network just released their encrypted mempool white paper a few days ago. So how can TE-based block building complement such kind of approaches? in any what way? Yeah, thank you. Yeah, the question. I would like Chua to start first, then Shay. Thank you.
Okay, so if we think about it, like in terms of having an encrypted mempool, I think I kind of like touched a little just now. In this case, what we can do is TEs. We can actually have multiple TEs, each running like a version of a software that would you can imagine that it is actually the trusted execution environment would run a RPC endpoint that allows users to actually submit transactions into it. And if you think about it, the users would like encrypt their transactions that they want to have, specific to the trusted execution environment that they want to interact with. When the transaction goes into that mempool, it can be shared with any other TEs that have been mutually attested with one another. That means both the so-called the mempool TE and any other parties that wants to access this information. So this actually allow us to I mean, some people might imagine that we have one single huge big server that runs a TE and everyone will connect to this TE to submit transactions in, and we have one huge mempool that is being persisted within the trusted execution environment and hence encrypted. That is not really the case. The mempool can be thought of something like an abstract notion where it can be distributed across many different trusted execution environment endpoints in which they actually form a network, and you can actually obtain what's it called, transactions from one another if you have been verified to be authentic, so to say. And this actually kind of like brings up the idea on would this actually allow us to level the kind of like playing field that small searches level the playing field among like big searches and small searches because of the presence of private order flows. Because I think we can all agree that the largest contributor to having a good block, or a block that has a high value, actually comes from all this private order flows. And if we have such a kind of like encrypted mempool where no one can have an advantage over one another, we kind of like level the playing field for all the participants of the system. And this would hopefully actually kind of like push the development of like more effective, efficient searching strategies. So yeah.
I don't have a whole lot more to add.
I would be interested in switching gears a little bit and talking about what other like applications you imagine TEs being useful for. And so one of the ones that I know Flashbots did a collab on was with Azuki and the whole I'm blanking on what it was called now, but allowing people to tweet on your behalf. And so like there's this Web3, Web2 kind of connection there at the app layer, which I think is really interesting and kind of got my wheels spinning for a while. Or maybe in the interoperability space, there's probably some applications there. I'd be just curious from both of you on what excites you outside of kind of the MEV space for TEs.
Ooh, okay, so we can't, no MEV allowed, entirely non-MEV apps. You actually you named one I would probably cite. The Azuki collab that you're mentioning, Blair, is I think part of this broader family of products in the sort of account encumbrance space, which is basically this idea that, and there are other people at Flashbots who've been doing all sorts of very, cool moonshot work on this. So you should check out their work as well. But I think one kind of cool idea here is that TEEs can let you not just, read data from Web 2 into Web 3, but actually write. So, the Azuki thing Blair is talking about is we have this app that some of our researchers developed called Teleport, where you can basically give someone the ability to tweet from your account by sort of encumbering it. And you can also apply sort of specific rules with an LLM that kind of dictate what kinds of things they're allowed to say or not. And so the Azuki collab was kind of one pretty interesting use of Teleport. And we've been taking the same idea of account encumbrance and messing around with a bunch of other things. Anything you think of, you could probably encumber. I think there's also a personal favorite moment that happened for me. Let me see if I can find this. This was really funny. This happened at ECC. Oh, I'm not going to find it. It's really far back. But we basically there's this game. This game people play that basically you're kind of like trying to not get voted off the island, if I'm remembering correctly. And our researchers realized you could create a TE that sort of allowed people to collude and make sure that they won the game. And it did so well that the actual people playing the game in real life discovered it and banned them from the game. But the TE kept being used. So like secretly this thing was really good and everyone was using it even though they kicked off the creators from the game. I need to go grab the actual example because I'm forgetting the details. It was over the summer. But this kind of stuff, it's sort of this like jokester. This is very much a jokester spirit at the moment. I think is pretty fun. I think we're still figuring out where this possibly goes, but that's one category. If we're not allowed to talk about MEVX, that I think is really cool. People should check it out.
For that example, you would say it's like the trustless collaboration that is the kind of positive sum feature.
Yeah, and I think it's this ability to delegate control of accounts to a TE and make rules for how it can behave. I think is really the account encumbrance part plays a big role there.
Yeah, that's cool. Chua, do you have any non-MEV examples of TEs that you're excited about?
Yep. So I think right at the start of the space, I've kind of like mentioned about like the usage, the combination of TEs with other cryptographic primitives, for example, like TEs with MPC that would help prevent like collusion between the MPC nodes and make the whole system more robust in general. TEs are also, if you ask me, very well suited to provide a kind of like very fast proof system. So for example, if we talk about say interoperability between all the different L1, L2s, all the different chains. One of the ways that we can do that is to make use of a TE to produce a kind of like a fast confirmation or a fast proof of a certain transaction being executed on the L2, and then the L1 can move on with it. On our end, we actually kind of like make use of TEs to provide like a multi-proof system for rollouts. You can think of it as multi-factor proof systems for rollouts. For example, we are working with like Scroll and Linear. Like Scroll and Linear are like ZK VM, so they have their own ZK proof system in which they will generate a validity proof about a state transition for their L2. At the same time, if you think about it, like if you want a system to be more robust, you actually want to have like diversity within the system. So, like we have multiple Ethereum clients to make sure that in the case where there is a bug in one of the client, it doesn't cause the the entire network to actually come crashing down. So it's the same idea but applied to like proving systems. You can have multiple proof systems. ZK proof systems are really expensive, like relatively to run, because it requires a lot of computation. It's very computation intensive. TEs can act as a really kind of like cheap alternative, because it's just as though you are running another VM. It's the cost of it is basically negligible in the grand scheme of things. Other than that, I think we are seeing more and more interesting applications of like quote unquote TEs. They are not like TEs in the traditional sense of like Intel TDX or SGX. Because if you think about a trusted execution environment, you can imagine it as being like what's it called, like a isolated environment. So using isolation based on hardware embedded secrets is one way how we can perform this isolation. But we can also have like physical isolations. Like there are projects that are they call it space TEs, where they send satellites up into space. So in those cases, those TEs, like space TEs, can act as kind of like your key backup. Like we talk about like um, uh, account abstraction, and how do we do like recovery for account abstraction. Can we actually make use of those space TEs, or like TEs in general, to act as a form of recovery, where they can hold part of the key shards that is required to regenerate the original key. That's something like food for thought too.
Okay, cool. We have 1 minute left, so I wanna open the floor to a listener. So who's been requested to speak for a while? I'll let him answer the question.
Could probably also do a comment in the chat thing.
So anyone has any questions? Okay, there's one. Yeah. So Rezo, correct me if I'm wrong. I already give you the permission to speak. Yeah.
Yeah, guys. Hi. Nice to have you all here. So my name is Rezo. I'm a VC initially since 2018 BR Capital, but I'm also co-founder of Super Protocol. So we've been working with this team. This team has 12 years of expertise when it comes to trust execution environment. We've been working with Intel directly and NVIDIA now, and we are actually the only Web3 project that was featured by NVIDIA on its website, how we solve the AI and big computational cases using TE technology. So we know what we are doing in that sense. For example, answering your question, what other use cases there may be? So there are so many use cases for TE right now, especially when we talk about the AI era and AI agents and intents, the upcoming intents, for example. So the easiest example is data collaboration, because TE enables privately to share and compute on top of the data. This opens up a lot of doors for new applications and new capabilities. Like we are talking about trading, about MEV, for example, right now, and any team or any trader that knows how trading works right now algorithmically, to be able to be trade, you need access to data, and the more private data you have, the more sensitive data you have that others don't have access to. It gives you advantages. It gives you ability to build upon on top of it. And MEV, so what we are building is Super Protocol, for example. It's TEE-based decentralized cloud, permissionless cloud. So what it enables, for example, is like, let's say that Flashbots has some proprietary data from blockchain or from traders or from the mempool or from this private traders or order flow. just as an example. It's not flashbots per se, but as an example. And then there are a lot of traders that want to develop AI agents or trading bots using some kind of proprietary data. Now, when it comes to AI or developing some kind of applications using big data, we all know that the better data you have or the more exclusive data you have, the better products you can build and the more insight you have, and you have advantage. And once we are talking about TE as a cloud, for example, so you can put your data into TE cloud, where it stays secure and private. Nobody can see the actual data. Like Shia can put her data, I can put my data. Some corporations can put their data, and then comes, for example, Blair, for example, comes and he is a developer. He says, okay, I want to build an application, an AI agent or some kind of trading bot. I want to use some specific data, domain specific data, and he gets access to all of this data.
Sorry, do you have any specific questions for our speakers here?
Sorry, do I have what?
Any questions for our speakers today?
The question, I have some questions, but I was just bringing an example how TE enables collaboration on the data. This is your last question to the speakers. So there are a lot of usages for AI.
Time is kind of limited, so it'd be great if you have questions. So.
The question, yes, do we have currently, when we come to flashbots or automata, or we're talking about the decentralizing TE, do we have a technology that enables to decentralize actually the TE stack to enable a decentralized launch of nodes based on TEs? Is this technology ready? Because we are participating in building that. Aside from that, in the trading activities in our DeFi side of things. So do we have a technology that enables today to decentralize the TE stack? I know that Unichain is going to use the Flashbots technology for decentralization and BuilderNet possibly. So some insight into how are we decentralizing this stack would be very useful.
I think creating a decentralized network of TEs is sort of the express goal, or one of the express goals of BuilderNet. We have a roadmap on the buildernet.org website, which has a little bit more information about how we're thinking about that, which I might point you to if you want to see more of the plans on the decentralization front.
Okay, yes, thank you. I know the BuilderNet, we looked into it, but there is no architecture or specificalities about this, and this is a very crucial part of Unichain and Flashbots and BuilderNet. Okay, so we don't have a stack right now.
I think I'm not quite sure what you're looking for with the stack. This is obviously an active area of R&D, so there's a lot of kind of ongoing conversations. If you want a lot more detail, we have a forum. The Flashbots forum is a good place for some of this stuff. Also, basically everything we do is open source on GitHub. So if you're looking for more technical details about the actual work we're doing, those are good places to look. And I might turn it back to the host because I think we're at time.
Yeah. So it's already more than an hour. So I think that's a great wrap up. And actually, Shay just released BuilderNet 1.2, right? So also Flashbots has a roadmap on the website, buildernet.org, right? So I think Rito can find more information there. All right, so thank you guys. Thank you very much for joining this Twitter space. So hopefully we can have more things to talk about in terms of regulation and compliance, but I think we'll leave that to the next one. Okay, thank you guys.
Thanks all.
for having us.
Thank you all. Bye-bye.
Thank you. Bye.